electron beam welding. In the last of this topic I will show you the videos like we see for friction stir welding. Okay, so here just focus on this diagram of electron beam welding. So in its name itself tells us that what is electron beam welding. There is a production of electron beam, and using this electron beam we are going to make the weld. So not much more different. Just in this diagram you can see here the main component, high volt supply. It is connected to the cathode one. Then this cathode, after this they are having preliminary anode, then focusing coil. From this cathode the electrons are emitted, and these electrons get attracted towards the preliminary anode, and this preliminary anode, after this the focusing coil focuses this emitted electron and focus it on the workpiece. Then between this there is a having focusing coil and a deflection coil. Okay, so now we are going to make some introduction of this electron beam welding. Just hear carefully. Electron beam welding. The major characteristics of electron beam welding is greater depth of penetration occurs by high accelerated electrons. Electron beam welding is a focusing process where the fast moving electrons hit the metal surface, which transfers kinetic energy of electron into thermal energy. This energy can be used to melt and fuse the material being targeted. If this process is carried out at junction of two metal plates which are to be welded, the fusion weld causes welding. Then we are going to see the welding of this process. Working. The electron beam welding is performed at high voltage under vacuum environment. The generated electrons up to 100 kW for depth section sliding toward the anode by electric field in the tube and its magnetic focus toward the largest surface of workpiece. When the electrons are traveling toward the target, there has no pass to the anode of the equipment. The main function of anode is to attract the electrons that are sent toward the target without allowing them to distract from their path. In between, magnetic lenses are used to absorb low energy electrons and to allow the converging electrons to pass. In addition to this, electromagnetic lenses are used to focus the beam of electrons upon the target workpiece. This enables very deep penetration to achieved with a keyhole penetration mode at fast travel speed, providing low overall heat input. This hole is immediately filled by molten metal from reservoir and form the weld upon solidification. The electron beam machining 3-axis tables are used for the workpiece holding purpose. Electron beam welding application can be seen in aerospace industries as well as automobile industries. A material like titanium also can be welded by using electron beam welding. Now we are going to discuss the parameters of electron beam welding. So here I already listed the elements, parameters of electron beam welding. Electron beam accelerating voltage, then beam current, and electron traverse speed. So I am just explaining one by one. The electron beam power. This power of electron beam is constant over a large working distance, but the power density decreases with distance, giving broader, less penetrating welds. Then accelerating voltage. Depth of penetration is depending upon accelerating voltage. Depth of penetration can be increased by increasing accelerating voltage. Then beam current. Beam current is directly proportional to acceleration voltage. Therefore, depth of penetration can be increases or decreases with by increase or decrease of beam current. Then electron travel speed. As travel speed is increased, penetration is reduced. Since the electron beam has tremendous penetrating characteristics with a lower heat input. The electron beam spot size. Beam spot size can be concentrated to 0.5 to 3 mm diameter. Small spot size produces narrow weld geometry. Then we are going to see the advantages of electron beam welding. The advantages of electron beam welding are already listed here. You can see the advantages of electron beam welding are: material having the higher hardness value can be joined. As the technique is performed in vacuum environment, there are no impurities left by the process, thus having high weld properties. Absence of filler material brings the operating cost down. It provides a small heat affected zone with minimized distortion and material shrinkage, and less welding defects are produced. Now, disadvantages of laser beam welding. A skilled operator is required. Depending on the vacuum chamber, the workpiece size should be allowed. The initial investment is higher in case of electron beam welding. Electron beam welding can be replaced by laser beam welding, where only a laser source is used instead of electron beam. Now we are going to see its video. Here you can see electron beam welding machine, that how this machine is actually existing. So this is the vacuum chamber. In this the complete process is going to be happen. So this is the cathode, then bias, then anode, which is in the form of preliminary anode. Then this is, you can see, this is the beam of beam of electrons, which is formed from the anode and concentrated by laser anodes, just to be focused on the workpiece. This is focused between the gap of the two plates which are to be joined. Now our next another concept is of laser beam machining, just same as that of electron beam machining, only we are producing the laser light instead of electron beam. You already studied this topic in manufacturing process too. So now we are going to take another topic, which is ultrasonic welding. The image of ultrasonic welding you can see on your screen. So this is the diagram for ultrasonic welding machine. Okay, so its important components are transducer, then converter, booster, then sonotroc, then horn, and it is applies vibration on the vibrations with frequency on the workpiece, which is to be welded or which is to be joined. Okay. Now we are going to see this working principle of this ultrasonic welding. Ultrasonic welding, the workpiece to be welded is placed on an anvil, and ultrasonic vibrations are generated in transducer, and the vibrations are transmitted to sonotrode, and vibratory motion is supplied. Because of its motion, frictional heat is generated on contact surface between the workpiece and the weld is completed. Here I already listed some advantages and disadvantages. Before this, we are taking this discussing about the components of this ultrasonic welding. Power source or generator provides high voltage signal at desired frequency trailer, typically about 20 kilohertz. This power is needed by the transducer to generate vibrations. Transducer and converter. The transducer is the key component of ultrasonic welding machine. With the help of transducer, the electrical signals can be converted to mechanical vibration in the range of 20 to 40 kilohertz. Transducer consists of number of piezoelectric ceramic sandwiches between two metal blocks. Between each of the discs there is a thin metal plate which forms the electrode. As the sinusoidal electrical signal is fed to the transducer via the electrodes, the discs expand and contracts, producing an axial peak-to-peak moment of 15 to 20 nanometers. Then we are going to see this. It's having booster, then heart, then anvil, then working. The workpiece is held are placed between the anvil and opposes clamping force. Two workpiece surfaces held together under the pressure of horn. The ultrasonic vibration is generated in a transducer, and the vibration is transmitted through a sonotrode, and vibratory motion is supplied. Because of vibratory and oscillatory motion, frictional heat is generated on contact surface, and the molten metal is flow into the joint surface. Melting rate increases, resulting in increased weld displacement, and the part surface fully meet. The horn get retracted, and the welded material can be removed from the anvil. Now we are going to see the advantages of ultrasonic welding. Welding strength is high. Welding strength of ultrasonic welding is high. Non-similar metals can be welded. Very less amount of heat is produced in the operation. Now discussing about the disadvantages. Not used for thick metals. A specifically designed holding device is used in operation. Electronic components should be protected from the vibration generated in this process. Now we are going to see the Animation of these ultrasonic machine. Now focus on your screen and try to understand this ultrasonic machining.
Welcome back to another video of Engineers Academy. Today we will learn about ultrasonic welding. Its principle, working, equipments, I request you to consider subscribing to our educational channel and the welding process in which ultrasonic waves or vibrations are used to generate heat for welding. Ultrasonic means those vibration waves which have frequency above the normal hearing range. It is about 20,000 to 30,000 Hz. It is a solid-state welding process. Solid-state welding is a welding process in which no external heat is added for welding. It works on the basic principle of energy of ultrasonic wave. Ultrasonic vibration creates a dynamic shear stress between the contacts of two workpiece. Due to local plastic deformation and heat generate due to friction between contact surfaces, joint. Let's talk about the equipments used in ultrasonic welding process. First is power supply transducer to generate vibration signal into high frequency mechanical vibration. This is connected with the welding head. The converter or piezoelectric transducer used in this welding process. Third is booster and horn. The mechanical vibration created by the transducer is supplied to the booster which amplifies into the welding. This uses either electrical, hydraulic concept of ultrasonic. This transducer converts high-frequency electrical signal into mechanical vibration. This vibration further supplied to the booster which amplify its frequency. The amplified high-frequency vibration passes through horn which is in contact with welding plate. This welding creates lap joint. One plant of the weld is fixed into fixture and other one is in direct contact with horn. These plates are fixed under moderate pressure force. The horn supply high-frequency mechanical vibration to the welding plate. Due to this vibration, oscillation shear force act at the interface between welding plates which result elastoplastic deformation at interface. It also create a localized temperature rise due to mechanical force and friction. This heat helps in plastic deformation at interface and makes a strong joint without melting of workpiece or using filler metal. Let's talk about its advantages, disadvantages, and application. Advantages: good surface finish after welding. Molten metal form joint. Disadvantages: it does not weld thick harder metal. The thickness of welds about 2.5 mm for aluminum. Tooling cost for fixture is high and they also need special design. The vibration generates through transducer, can damage electronic component. Applications: this welding is used in fabrication of nuclear reactor components. It is used in automotive industry for key, headlamp parts, button, and switches etc. Ultrasonic is used in electronic industries like armature winding, switches etc. This is clean welding process so it is used in medical industries to make parts like filters, masks etc. This is all about ultrasonic welding process. If you have any query regarding this video, ask us by commenting. If you like this video, hit like and don't forget to share it on your social networks.
Now we are going to start another topic.